Hi guys, welcome back from the ad break. So I hope you really did try this out, right? But let's quickly just have a look at it and then we'll continue with our lesson. So what you guys needed to do here is remember the laws that I gave you when we're looking at the rational exponents, right? We said that the first part here will be the same as x to the exponent of 1 over. So firstly, let me remove the 1 over there because my 3 needs to still be there. So it's 3. And because it's a square root, it's 1 over 2, right? And then multiply by this one here will be x to the exponent of 2 multiplied by 1 over 3. All of this divided by x to the exponent of 1 over 6. And then I'm sure from here you can then see what's happening here. You just apply your laws of exponents. Firstly, distribute the exponents and then apply the multiplication and division laws. So this becomes 3 over 2 multiplied by 2 over 3 divided by x to the exponent of 1 over 6. And then lastly, this will be x to the exponent of 3 over 2 plus 2 over 3 minus 1 over 6. And then you can always find what that answer is, right? But my LCM here will be 6. So it means for this to be 6, I multiply it by 3. So that's 9 plus that 6 there, that 4 I mean. So it will be x to the exponent of 9 plus 4 minus 1 all over 6. Which will then be x to the exponent of 9 plus 4 is 13 minus 1, that's 12, divided by 6 will just be 2. And then that will just be my answer there, x squared. That will be the answer, right? So I hope you really did try that out and you are seeing your mistakes and you're seeing what exactly you needed to do there. The goal was to change the sets and make them what we said they will be, which is an exponent that is rational, and then from there and then apply your laws of exponents, distributing, multiplication, and then division, and from there you can get your answer. Let's look at some more work that we need to do now. So remember, this is our concept map. We've looked at all these beautiful concepts that we have here. Now we have what we call sets, right? Remember I said this is one of the keywords that we are doing. Now, a set will be an irrational number, excuse me, of the form root of a. Now, the condition for this to be irrational is, 1, my a must be greater than 0, so it must be a real number, right? Real positive number, that is. Real number, but the condition is it must be positive. Then number 2, a is not a perfect square. So a must not be a perfect square because as soon as it becomes a perfect square, it will no longer be an irrational number. It will now be a rational number, right? Remember, root of 4 will be equals to 2. So that's not an irrational number. But root of 3 will then be a decimal of some sort with a non-ending decimals there. So some laws of sets that we also have here is, if I am multiplying sets that are the same, the rule is you multiply what is inside the set. But remember, listen to what I'm saying. They must be the same, the sets. So you cannot say the cube root of 2 multiplied by the square root of 3, and then you now want to multiply the 3 and the 2. No. It must be the cube root and the cube root for you to be able to multiply what is inside. It must be the 5th root and the 5th root for you to multiply. That's why I am using n there as my general term. Similarly with division, it must be division of the same root, right? And then you will be able to divide what is inside there. Similarly with the example that I just made, it can be square root of 2 over maybe the cube root of 3, and then you want to say you are dividing what is inside the exponents. Please do not do that. Inside the sets, I mean, right? So it must be the same radicals. We normally actually call them radicals. So it must be cube root and cube root, then it will be 2 over 3, and all of this will be inside the cube root. This is more or less the same as the laws of exponents, where if I have an exponent outside, I kind of distribute it inside to everything that I have inside the bracket. Some more interesting laws will be if I have the mth root of the nth root, it will be the same as me multiplying those, what root it is, right? So if it was 5 there and 6 here, it will then be 5 multiplied by 6, provided that it's just one term inside there. And then the last one will be if I have the mth root of a, all of it raised to n, it will be the same as the mth root of a to the exponent of n, right? But let's look at typical example and actually see how do we do this. Firstly, here it says simplify the following. I have root of 3 times root of 5. The question you must ask yourself is, are my radicals the same? If your answer is yes, then you can multiply what is inside the radicals. If your answer is no, then look at some other method of solving this. But now, because they are the same, this will be the same as root of 15, right? Then plus, here I will have this as the same as root of 15 multiplied by root of 3. All of this divided by root of 3, right? Why am I writing the one at the top as root of 15 times root of 3? It's because my 45 here can be written as 15 times 3, right? And since both of them are inside the same root, I can then separate them with 1 root each. Remember, it's just the law that we looked at, the very first law of multiplying sets. And therefore, this will be that root 3 and that root 3 will divide each other, and I will have 2 root of 15. Now, please don't make the mistake of thinking this is actually supposed to be root of 30, right? Because that's one of the mistakes that you guys make. You think you can add what is inside there and what is inside there. I think maybe a typical example of this, I can say to you, I have 1 root of 15. I'm adding it to 1 root of 15. How many roots of 15 will I have? 2, you see. Therefore, it becomes 2 root of 15. So it's the same as 1 apple plus 1 apple. It's 2 apples. It can be the apple plus the apple, and then you get something else there. Please make sure that you understand that clearly, please. Let's look at another example here. So this is an interesting one again. Remember, I said my radicals must be the same for me to apply my laws, right? So this will be the same as the cube root of everything that I have here, 16 over 2, plus what I have here is the fourth root, so it will be 4 outside, and then inside here I will have 2 multiplied by the 8 there. Then remember, 16 divided by 2 is supposed to be 8, and then it means I will have the cube root of just the 8, plus here I will have the 4th root of 16, right? And then normally they say to you without the use of a calculator, so make sure that you do try to master this without using a calculator. This will be the same as 2 to the exponent of 3, that's 8 still, right? Then remember, raised to 1 over 3, plus this will be the same as 2 to the exponent of 4, and it will be raised to 1 over 4. Why am I choosing 2 specifically? Is because I said to you, when changing these things to be exponents, your basis must be prime numbers at all times. Don't write your base as a number that is a perfect square or something like that. It must always be your prime numbers, please. So the lowest prime number that 8 has will be 2. The lowest prime number that 16 has will then also be 2. If I had a number that its prime number is 3, then I would use 3, right? So that's why I'm choosing the 2 specifically. Now, to simplify this, 3 multiplied by a third is 1, so I will be left with just the 2 there. And then 4 multiplied by a quarter, it will just be 1 as well, so I will be left with a 2 there, and then my final answer will be 4, right? And then because you guys have these beautiful gadgets of yours, which we call calculators, after working this out, you can always just press the whole thing the way it is, and the answer that it must give you must be 4. If it does not, it means there is something that you did not do right with your working out there. So that's just how you test yourself whether you got it right or not. Another example that I have here is it says simplify the following. So I have the 2 outside there, right? And I have the 2 outside there as well. So this will be the same as 6 to the exponent of 1 over 2, right? And this will be raised to the 2 outside there. Plus, this will be 10 raised to 1 over 2, and then there's a 2 out there. Lastly, this will just be 6 plus 10, which is then 16. Or, if you apply the laws, this will be the same as the square root of 6 squared plus the square root of 10 squared. And then you know 6 squared will be the same as 36 plus 10 squared will be 100. I'm sure by now you know your square roots, guys, for the perfect squares. This will be 6 plus 10, which is definitely 16. And that's where your answer will then come from. Another one will be, remember the first law we looked at, we said we distribute this, even that we distribute it there. So this will be 5 squared. Remember the operation in between there is multiply, and this will be the square root of 3 squared, and then plus this will be the square root of 8 to the exponent of 4. And 5 squared we know is 25, multiply by square root of 3 squared will be 3, and then plus, so here I will have this the same as raised to an exponent of 1 over 2, so it will just give me 8 squared. And 25 by 3 is supposed to be 75, plus 8 squared will then be 64, and then you can add these numbers. This will just be the 9 there, add these 2, it will be 13, and that becomes my final answer there. Then you can play around with your answers there. Please, guys, the goal is to try and firstly look at if I can apply the laws. If not, then just apply the normal way of solving these things, where you multiply it by itself. And then another example, which is quite an interesting one now, will be, will be to firstly change the bases, right? I did say that. So this will be the same as the square root of 2 to the exponent of 4n minus 8. Where do I get that from? Remember, 4 is the same as 2 squared. Then I multiply the 2 by 2n minus 4. And then that's where, my 4n minus 8 comes from. Multiply by 2 to the exponent of 3 into 5 minus 2n. All of this is divided by, this will be 2 to the exponent of 4 into the 6 minus 2n. I'm thinking to just write it so that people can actually see where these things come from. And this will therefore become, so here, because I'm going to raise this to the exponent of 1 over 2, it will then give me 2n minus 4 times 2 to the exponent of 15 minus 6n, and then divided by, this will just be 2 to the exponent of 12 minus 4n. All right, so from here you can then apply your laws of exponents, and by that I mean the 2n, the 6n, and the 4n will then be worked out together. The -4, the 15, and the 12 will also be then worked out together. So this will become 2 to the exponent of 2n minus 6n and minus negative 4n, right? And I will just write the whole thing as well, -4 plus 15, and then minus the 12. So this will therefore become 2. The 2n minus 6n is minus 4n. The minus and the minus, they will give me a positive. Therefore, it's minus 4n plus 4n, which will be 0. Minus 4 plus the 15 will be a positive 11. Then 11 minus the 12 will just be negative 1. Then finally, my answer will be 1/2. So guys, as you can see, the goal that we've been trying to do here is always make sure that your exponents are changed, right? Not are changed using the laws of exponents, meaning if it's multiplication, you add, if it's division, you subtract. Also, when you are changing your powers, make sure that the bases are in the form of prime numbers. Why I'm saying this is because let's say, for example, we have 12, right? 12 is the same as 4 times 3. But if I write it as 4 times 3, I also need to go again and add another step of changing the 4 to be a 2. So I can just go straight to saying 2 squared times 3 and then continue from there. So always make sure that you change your bases to be prime numbers. Guys, from me to you, I want you to please take a walk a bit around the house, drink some water, and freshen up, and we'll be back with some more.